So we'll look at problems from chapter 3. The first problem that we'll look at is problem number 2 from your textbook. The problem says you are an international shrimp trader, a food producer that is in the Czech Republic, offers to pay you 2 million, but note this is in a foreign currency, Czech koruna, today in exchange for a year's supply of frozen shrimp. You have another supplier, a Thai supplier, who is offering you the same supply, same quantity, but for 3 million Thai baht today. If the exchange rates today are 25.50 and 41.25, which one would you choose and what will be the value of this exchange to you? So, if we look at this problem, essentially we have to assess the value of the two alternatives in a common currency. And what's the common currency that we will be using? We will be using the common currency of the US dollar. So what we can do is we can take the Czech koruna and convert that into US dollar. Take the Thai baht and convert that into US dollar. So the THB and the CZK, we convert that into US dollar. So what's the conversion? How do we convert koruna into dollar? Well, we see that the value of one koruna, or $1 is worth 25 koruna. So this is 25.50 koruna per dollar. So $1 is worth 25.50. So now the question is, what would be 2 million korunas worth in US dollar? So that would be 2 million. We will divide that by 25.50. And the logic is pretty simple and straightforward. Just to plot out the logic for you here. So in the numerator, we had CZK, right? This is the amount of koruna. So that's CZK in the numerator. If I divide this by CZK per dollar, then what happens? What happens is that the CZK and the CZK cancels. And I'm left with 1 over $1. 1 over dollar, which is equal to the dollar. So all of that converts this amount into US dollar, and that conversion is 78,431 US dollars. 78,431 US dollar. I have to do the same thing. I have to do the same thing for so I will do the same thing for the other currency, which is the Thai baht. We had 3 million in Thai baht. We will divide that by the Thai baht per dollar, 41.25, and that will give us $72,727, $72,727 in round numbers in US dollar. So if I used the Czech dealer, I would be paying this much in US dollar. If I use the Thai dealer, I would be paying this much in US dollar. Obviously, this would be the preferred choice, and the difference is approximately $5,700. So 78,431 minus 72,727 is approximately $5,700. approximately 5,000. That's the value of this exchange to you, 5,704. So essentially, this is an example of a cost-benefit analysis. You're looking at different alternatives, and that's what most finance is about. You're looking at alternatives and trying to evaluate which one gives you the most cost-effective way of conducting business. That's a simple example. Let's take another example. This is slightly different. Problem number 11 from your textbook. You can take a moment to read the problem. So the problem says that your friend asks to borrow $55 from you, and in return will pay $58 in 1 year. So $55 from you today will pay you $58 in 1 year. That information I can immediately put into a timeline. $55 today will be paid back as $58. Today is time 0, a year from now, 1 year from now. And at the same time, you have another alternative. This is the bank, which is offering you another alternative, 6% interest rate on all deposits and loans. How much would you have in 1 year if you deposited $55 in the bank today? So instead of taking your friend's deal, what if you accepted the bank's deal? So I'm going to be depositing $55 at time 0. My question is, what will be my value, my future value in time 1? What will be my future value if this was earning a 6% rate of return? So one way to find that out is to apply the future value formula. Future value in period 1 is present value, which is this number. $55 represents the present value because it's at time 0. I multiply that by 1 plus R. So it's 55 multiplied by 1.06. So 55 multiplied by 1.06 is 58.30. Which is slightly more than what your friend had offered. Another way of solving this problem would be to use the financial calculator. It's a simple example. For this particular problem, the financial calculator does not give you as much of an advantage as the direct application of the formula, but it may be still useful to start learning about the financial calculator. So as I explained in class, I'm going to repeat it again over here, some of the steps that you need to do to prime the calculator. Number 1 is, and whenever you do any time value money problem, do a second and TVM, so that clears all of the values that are stored in your previously solved problem. So you always do that step before you start using the problem for a calculator. So 55 represents your present value. The calculator convention requires us to input present values as negative number. So I click the negative key and then the present value over here. So PV is 55. N is 1. IY, interest, R is 6% IY. Now I have to calculate future value. So I do compute future value and it gets to 58.30. So I can use the calculator method if I choose to over here. The part B of the problem says how much money could you borrow today if you pay the bank $58 a year from now. So now it is taking the same problem and reversing it, asking the question, if you were to pay $58 a year from now, what will be the present value of that $58? So this time you're calculating present value is future value divided by 1 plus r. So present value is the unknown, future value is 58. I'm going to divide that by 1 point. I'm going to divide that by 1.06. And if I do the math, that comes out to 54.72. Alternatively, I could have used the financial calculator. Again, I do a second clear TVM, clear everything out. So now 58 represents my future value. I don't have to enter that as a negative number. Only present values entered as negative numbers. Just a calculator convention. N equals 1. IY is 6%. Now I'm computing present value. So that's 54.72. And the third part is just a qualitative question. Should you loan the money to your friend or deposit it in the bank? Of course, the bank is giving you a higher future value than your friend is giving. So, of course, from a cost-benefit analysis, you would choose the bank over your friend's offer. Question number 15 is a different type of a time value money problem. It's a multi-year time value money problem. It is telling you that you are considering a savings bond that will pay $100 10 years from now. If the interest rate is 2%, what should you pay today? So from reading this problem, you have to first identify what these numbers represent in terms of our time value of money variables. This is $100 that will be paid 10 years from today. So that's future value. That 10 year, that represents my N, the number of period. That 2% represents my R or IY. And what will you pay today? That's my present value. So in terms of my present value, future value formula, I know that present value in a multi-year framework is future value at period n divided by 1 plus r to the power n. So I could solve this $100 divided by 1 plus 0.02 raised to the power 10. So that could be one way to solve the problem. And if I did it that way, present value is 82.03. Okay, it's pretty straightforward and simple. Alternatively, I could have used the financial calculator. Again, I do a second clear TVM, and I enter 100 as my future value, 10 number of periods, 2% as my IY, and I'm computing present value. Note there is a negative sign in front of that number. We ignore the negative sign, and the answer is 82.03. Okay. Let's look at a different type of a problem over here. This one is kind of like the problem we did earlier, which is looking at cost-benefit analysis across different currencies. So you have an international food supplier that is offering to supply, is offered 9.5 million yen today for 100 pounds of a type of fish. 1,000 pounds. And this 1,000 pounds can be sourced from different countries, and their cost for those 1,000 pounds are in the following currency. we also have the exchange rates for the different currency. Again, which is the best deal that you can make and what will be its value. So if you start with the yen, you have 1 US dollar equals 102 yen. So you have we have 952,000 yen. So that's our yen. And I want to convert that into US dollar. So to convert yen into US dollar, I will divide this by yens per dollar. So again, like we did before, the math is pretty straightforward. The yen and yen cancel, leaving me with 1 over dollar. That will give me the dollar value of, which would be 952,000 divided by 102. That will give me the dollar value of this deal. And once I have the dollar value of this deal, let me see, I have it over here. The numbers worked out. So I have the numbers over here worked out, 9.52 million. So 9.52 million divided by 102, that gives me 93,333. Similarly, I could have done this with other currency, each of the other currencies. And what I found out was the New Zealand deal was the best deal. I'm taking the New Zealand dollar, dividing that by 1.3 New Zealand dollar per US dollar, and that gave me a value of 80,000. The difference between these two is the value of my deal of 13,333. So I could have worked it out in this manner. Again, the same type of problem that we have done before, looking at cost-benefit analysis across the different options we have. Okay, I want to go back over here to what is the present value of 90,000 received 6 years from now, assuming a 5% interest rate? Again, anytime you have a problem like this, one of the first thing you want to do is convert that into a timeline. So you're going to receive 90,000 when 6 years from now, and you have to calculate the present value of that 90,000 today. What is the present value today? The exchange rate, the interest rate is 5%. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So there are again two ways of doing it. We can use the formula method. Present value is future value in year 6 divided by 1 plus r to the power 6, which would be 90,000 divided by 1 plus 0.05 raised to the power 6. That's pretty straightforward. Or I could have used the financial calculator method. I clear everything. Second, clear TVM. Choose the 90,000 as my future value. So 90,000 represents my future value. It's 6 years from today. So 6 is N. And IY, interest, is 5%. IY is 5%. And I'm going to be computing present value. So that's going to be 67,159. Okay. Simple, straightforward problem. We can use the financial calculator method. If you use the financial calculator method, then try to write out the variables on your sheet of paper so that you can go back and check your work. And the way to do this, you can write it out like this: FV6, 90,000, IY 5%, N is 6. What am I computing? From this, I'm computing present value. So now when you go back and revise your work, you will see that these were your inputs. This is the output, and that's your answer. So that would be a logical way of approaching problem solving in finance. Same thing here, taking the other aspect of this. This is again one-time cash flow. What will be its future value? So this time what I do have is I know the present value this time I know is 50,000. That's the present value. So this represents my present value. Now I have to find out the future value 30 years from today. So what's the future value in year 30? Where interest rate is 6%. So one way to do this is to directly use the formula. Future value in year 30 is present value times 1 plus r raised to the power n. So this 30 represents my n. Present value is 50,000. 1 plus r is 6%, and n is raised to the power 30. Or I could have used the formula, the financial calculator. Again, clear, TVM. 50,000 is my present value, but the calculator convention is to change that to a negative sign. That's my present value. 6% is my IY. 30 is my N. And I'm computing future value. So that's 287,174. Rounding the numbers. 287,174. That gives me the future value of this cash flow. So that completes the problem tutorials for Chapter 3.